Messy Jesse here with the Vault Sound Solutions. Today we're working on a Stetsom EX3000EQ. This is the 1 ohm model. This amplifier has some problems with the power supply section here. It's not very happy anymore. This also happens to be the same style amp as a Timpano TPT3000EQ. I'll leave these here for just a second. You guys can pause the video if you like. Very close to the same amplifiers, if not the same amplifier. Once again, that's the Timpano, that's the Stetsom. So I already can see right here that the transistors, the power transistors, have failed. We're going to go ahead and remove these real quick. So once the board's out of here, I'm going to go ahead and take all these power supply transistors off because not any of them look any good. We'll measure them. If there's a pair that's not shorted, I will put them back in because I do not have any in stock for testing right now or for reinstallation. I just used my last pair yesterday, or my last batch yesterday, I should say. Okay, so now before I relocate that too much, we'll try to get you guys a little close-up carnage shot. See if I can't focus this a little better. I have to be back farther to see that one. Alright, let's see if we can't get that in there some. Alright, so we'll take this out of the board. I want to leave all these thermal pads, thermal insulator pads on here for now. Okay, something here also went out. It looks like this transformer has been rattling. It has been. This transformer has just been floating freely here. The zip tie had broke. Probably due to heat. Let's see, is this brittle? How brittle is it? Yeah, so this got, oh yeah, look at that, this got hot. I could just snap the zip tie in multiple pieces. So here's a zip tie here. And I want to see if I can crunch that up in my hand. So this is just falling apart. Let's turn the board over. There was a problem on the other side. It looked like it got hot here. I could tell because of the burn marks here. But I don't see anything that would have caused that, unless the fans were pulling air through there, and when this got shorted, it sucked some of the smoke through there. This is just floating around though. The terminal on the bottom, the enamel coating is scuffed off in one spot, but there is a cardboard insulator, so that should be okay. Let's go ahead and this is a 3,000 watt amp, and it almost fits in the palm of my hands, the board itself. So they're packing quite a bit of punch in here. We're going to go ahead and remove the power transistors. Now, if this is a 3,000 watt amp, which it does produce that power, these each are required to handle 500 watts of power through each transistor. That's quite a bit of power there. We're going to clean some of these up on this side because I don't think these have any issues. Try to eliminate some of the excess thermal grease everywhere. My camera glitched out. Let me go ahead and fix this real quick. Alright, we went ahead and looked at the carnage. The camera glitched out a little bit, so now we're back at it. I flipped this, the inductor is just loose floating around on the board here. We're going to go ahead and resecure that. What else? Yeah, we're going to go ahead and remove these bad power supply transistors real quick. We'll get the big iron over here. Yeah, these are literally just falling apart. It'll be a little bit more work to get these out than what I thought. So here in a second we'll go ahead and make sure all these leads are out. A lot of these leads are just falling right off the chips. I'll show you guys that in a second. These are some of the transistors. They're just in pieces. Take that guy off. Alright. Are there any more problematic pieces? Yes, one more I see that is sticking out here still. Take that out, okay. We'll get the solder sucker over here and clean all these holes up. Alright. Just cleaning up a little bit of the extra solder on this side of the board, so hopefully when I use a solder sucker from the other side it cleans these traces better. I'm going to add a little bit of flux. Some of these have a lot of thermal conductivity in this little iron. Not too happy with it, but we'll go ahead and clean up what we can right now. And go back with a bigger iron and try to heat the board up if we have to in certain spots and clean it off. Just trying to get some of the extra solder off of here. It's not cooperating too well. This board has a lot of thermal mass. So I'll try to remove some of the solder with the braided wick. One more to clean out here. Still acting a little difficult. Try to get this from the top. Oh, there's some glue on it. That might be the reason why. Not too happy. There we go. Okay, that's clean. So now that that's clean, and clean up this area a little bit. This board does not look the best. You see the before and after there, or halfway through rather. Go ahead and continue cleaning this. Just whatever over in this area needs to be cleaned, we'll clean. I see one more pad that needs to be desoldered. Go through one more time and wipe this off with the clean one. Try to get some of the extra debris out. Alright. It's looking pretty good there. I need to unsolder one more tab here, one more pad here. That may or may not do. Let me see if I can put the multimeter through it and multimeter lead through it. No. Oh, okay. So we'll have to hit that from the other side real quick. Center tab here. We'll let this heat up. That's better. Alright. Now I don't believe there are any shorts on these outputs, but we do need to check. This does have a short here. Okay. That one has a short. This one does not. So do we only have one shorted output transistor I'm going to remove. I need to reflow a little bit of clean solder on here to make this easier there. Okay, that comes right off. Now just since everything's hot still, we'll go ahead and clean these holes real quick. Still got to get some solder off of this pad. It's not wanting to cooperate. Still not yet. No, trying to let gravity do its thing, but it's not helping too much. Is that true? I'm just not seeing it through. Yeah, it looks through enough for me. No, there's still like a top cap on it for some reason. I'm not sure. Should Should have melted off by now. There we go. Now I should be able to get this bottom. This last one's being a little stubborn here. Still not happy, so I'll probably just heat that one little terminal up when I go to put that back in. I removed the wrong one anyway. That's okay. We'll move over to the next. Take this out. Straighten these legs out. Try to get that back in there. I got to first bring the solder to the tips of the leads. Then we'll be able to get this in there. Alright. Now that that is in there, I think it'll be okay. We can put that transistor to the side. Now we need to check for PWM modulation, pulse width modulation on the power supplies. Negative, positive, remote. Maybe we'll get a light of some kind. No, it's not happy. Something is shorted. I do see it here. Yeah, I thought I checked that, but on the top it is shorted. So we're going to go ahead and remove the shorted lead here. Solder bridge. I'll check on the bottom one more time. No solder bridges there. I'm going to clean this up just a hair more real quick. It's that whatever blue really got all over the place, so we'll try to clean up what we can. I'm looking at it from a different angle and now I see more soot. I'm going to get the hot air gun and get some of this alcohol dry. Now I'm not replacing any components this second, I'm just heating up the board to dry up that alcohol. And, from my understanding, alcohol is conductive. So now we'll see if we still have that short here. No, we do not have that short there, which is good. And we'll hook the remote turn-on lead up and see if we get a light. We do get a light there, it is trying to do something. So now we'll bring in the scope. It drifts a little bit, so we'll leave that scope up there and see if we got PWM here. No, we do not. Let's pulse it. See if we can get some. We can. Now the reason why that's giving me a sporadic signal like that, this knob here is kind of funky. I gotta clean my scope knob up, but I think it's the artifact that's there is just the knob itself. Let me see if I can make that apparent. This be the next. Right here be the next one. No, doesn't seem to have a oscillation there. Oscillation here. Yes. Was I holding the pin wrong, or did one of these resistors mess up? Yeah, I don't have oscillation on there, so the odds are that that mini resistor messed up. Surface mount resistor, but we'll check that out in a second. That's why we check all these pads to make sure everyone is firing proper. Okay, so it looks like just this one pad here is not firing proper. It is. Give it to me now. Okay, that's fine. So maybe I didn't have my probe set proper. Probe set correct. No, it did not give it to me that time. So let's probe before the resistor. There we go. And then we'll probe this again and see if the resistor just has a problem. Yes, so that resistor there is not allowing current to pass. It's open. If I check another one here, okay, that is shorted there. Not shorted, but that has contact. Sorry, rather. Okay, let me go to ohms. Get a resistance reading. This is a good resistor here. Let me probe this. We're at 2K. That doesn't seem right, but we'll continue to poke down the line. Right here is another resistor here. Might have to replace a few of these. Try to get a better lead on the contact here. Okay, we're sure that might be. Oh, that's the one that's open. That explains it. It's open, so we won't have anything on there. 2,000 ohms. Let me see. 2 kilo ohm. There could be something pulling up or pulling it down that I'm not seeing. I'm also going to check these resistors and see 1K3, 11 ohms, 10 ohms. So yeah, we need to replace all these resistors with 10 ohm resistors for the drive. That's way too high of a value. Okay. So we're going to end up needing to go through and replace these little resistors in here. See if we can't get on one of the resistors. Right there. You can see that it's messed up there too. Let me focus a little bit better if I can. So now the resistor itself is actually damaged. So these were 10 ohm resistors. Let me check in the, I think these are 16th watt. Could be wrong. Let me check in here for a 10 ohm. I might not have a 10 ohm on me. Might have to order them in. Not a problem. R. And I'm going to double check that this is a 10 ohm. Just to be sure. And when I probe these, I probe them through the package. I don't take them out yet. Give me 10 ohm. It says 10 R on it, so let me see 10 ohms. Yes, 10.2. Alright. So we're going to take the hot air. Well, actually, I'm just going to take this and put a little bit of solder on the end of the soldering iron. Heat that up, and that's going to come right off. I'm going to move right along here and take every single one of the 10 ohm resistors off. And just put them in the little soldering thing I have. There's another one here. So I'm going to zoom out real quick because we don't need to see all those. So I got some over here. We'll pick these up in a second. We don't have to worry about those right now. So we're just taking all these little ones off that relate to the 1, 2, 3, 4, 5, 6. So we did have drive before, but it was not acceptable. So we'll go ahead and put a little bit of flux back on each one of these. And then we will put the parts where they need to be placed. So we're using 10 ohm resistors here. And we're going to go ahead and take one out and get this on the board real quick. I'm going to go ahead and place all these and then we'll zoom back in for the soldering. Still just fighting with these little components. Go ahead and install these here. There's a total of 6 of these little resistors we're replacing. I don't believe the IC drivers failed. The driver for the PWM has failed because we were getting a square wave. I know it looked funny on my scope. My scope is not the best. It works. Definitely works. Okay, we got one more SMD resistor to install here. We'll take that out. I'm going to go ahead and cut the rest of this packet off. I'll put this back and solder that last one in place. You know, I'm actually going to leave these 10 ohms out. I bet the other amp's going to have the same problem that I have here. I have that Timpano amp I showed you earlier. If you're in need of an amplifier repair, feel free to message me, or if you have questions in regards to it, I'll leave the link in the comments. Let's try to zoom back down on a couple of them, see if we can't see what we're looking at. That's the big capacitor. There's a resistor there. We're going to turn our air all the way down on our hot air gun. Alright. I'm going to let that cool for just a minute. We'll move to the next one here. Now that did not automatically suck itself how I wanted it, so we're going to go ahead and oh, excuse me there. Bring you back in the shot. bit. See, that did not fall where I wanted it to. So I'm going to go ahead and reposition that. And reheat it. And that is installed there. Now we'll move to the next one here. And that's tucked back in there a little bit. So we'll go ahead and start flowing some hot air on this. And it's moving all over the place because I can't get this hot air gun directly on top of it. There we go, I got it in place there. Another one over here next to this coil. Heat up the area. Alright. It looks like it's installed. Let me double check once it cools down. Yes. We'll go ahead and move to this one here. Let's see if we can get that on camera. I have to spin this around. There we are. Go ahead and heat this up. Try not to heat the leg of the transformer up too much. Alright, that looks like it flowed in. Now we have one last one. Right here. Let's get you in focus. There we go. Now we'll heat this one up. Alright, I'm going to take you guys back to the full view now. Now we're going to go ahead and power this up again. The scope back on. And now we're going to check every output pad to make sure that their resistors are doing what they need to do. I have a blue light and that resistor is not functioning. Oh, that resistor was not soldered in place proper. Okay, let me hit this again real quick. Wonder if I missed that one. Okay. I'm going to go back to the pad there. Is this better now? There we go. Alright, that's happy. Now remember I told you my scope has an artifact in it. It makes that line. There's nothing I can really do about that. This trace just bad here. This one. I can't get PWM on that. Can I get PWM on this side of the resistor? Cannot. This side? No. So I'll have to make a jumper trace. It looks like there's a trace that's bad. I'll check that in just a minute. Go ahead and check this pad here and see what it's doing. Yeah, there we go. Check this one as well. Yes. Over here. No. Same thing as the other side. It doesn't like the center one. It's okay. We'll check this out. Over here, no as well. Okay. So I wonder if the trace has failed leading up to the resistors. Huh. I'm going to go ahead and manually touch a little bit of solder onto these small leads here. See if I can't get this a little better flow, I guess. See what's up. Maybe the hot air didn't hit these proper because it's underneath the transformer here. So I'm going ahead and manually soldering these a little bit. I'm actually going to get my really small iron on. See if I can't do some damage with that. Probably could have put some have some surface mount solder, the ball solder, little tiny balls of solder that melt, and probably could have put that here, and that would have given me a little bit better contact on these parts. Let's check it out now and see if it's any happier. PWM, PWM, PWM. Nope. Okay, I'll hit that back again. PWM. Nope. Okay. How about this one here? PWM. Yes. So we'll go ahead and retouch a couple of these up and see if that is the problem. If not, it's going to be a trace on the board, which I can make a jumper for. This did have a pretty nasty failure, so I wouldn't. My GoPro just clicked. I wouldn't be surprised if the trace on the circuit board had an issue too after the failure that it experienced. Okay, that's there. That's there. That one over here too, or not? Still not yet. Yes. Okay. So we're gonna go through all these again one more time. 1. Yes. 2. Yes. 3. Yes. 4. Yes. 5. Yes. 6. Yes. All right. I'm going to go ahead and clean up the area I worked at now so the flux doesn't get hard while I wait for the components for the next few days. Go ahead and order these in soon. Some 1404s. pretty good there. Now I do not have any transistors that I want to put inside there and test out. I have a feeling it might affect the board. If anybody knows of any transistors besides the 1404s that would work for this, please let me know. Even just for testing. I probably won't use them this exact time, but it doesn't hurt. Knowledge is power, so if I can know for next time, that's good as well. That's the repair for right now. We're going to stop here until we get some more components in. I'm going to go ahead and order in some of the IRFB4115s. I'm also going to order in some of the 1404s as well for this. I don't think anything else had problems on this board. Every time I look at it though, there's extra burnt stuff I want to clean off, so I'm just going to have to leave this alone and move to the next one. It's pretty well clean. There's no reason to sit here and play with this for a long time. I'll check a couple more things real quick though. Take the scope away. Cool. Checking a couple of the big components. On this side, I'm going to check these diodes. Alright. Cool. I think if we put some power supply transistors in this, this would fire up. This is all I'm doing with this board for now. When I get some more components in, I'll put the other half of the video in, and we'll continue. Thank you guys again. As always, please comment, like, and subscribe. I always appreciate the input. If you guys have any questions, feel free to leave me a comment. Either in the video, or I leave a link to my Facebook in the video. You can get at me there as well. Thank you guys.